Hello friends, welcome to my channel. In this video I will cover Objective Mechanical for Odisha Administrative Service Prelim 2011 examination. I will solve part 3. This type of questions they are very useful for ISRO examination and for engineering service and for ISRO examination also. Then all state PSU also they may ask this type of questions. Question is, the rotor shaft of a large electric motor supported between short bearings at both the ends shows a deflection of 1.8 mm in the middle of the rotor. Assuming the rotor to be perfectly balanced and supported at knife edges at both the ends, the likely critical speed of the shaft is how much? So critical speed we have to calculate. Delta value given. So we know omega n is G by delta root over. So G is 9.81. This is 1.8 mm is delta in mm. So you have to convert in 1.8 divided by 10 to the power 3. Then finally we will get 73.824. This is in radian per second. Options are in RPM. So 2 pi n is 2 pi n by 60. This is 73.824. N value we have to calculate. N equal to 73.824 into 60 divided by 2 pi. If we solve this one, you will get 705 RPM. B is the answer. An epicyclic gear train is shown schematically in the given figure. The shown gear 2 on the input shaft is 20 teeth external gear. The planet gear 3 is 40 teeth external gear. The ring gear 5 is 100 teeth internal gear. The ring gear 5 is fixed and gear 2 is rotating at 60 rpm counterclockwise. The arm to attach to the output shaft will rotate at. So from here data given are gear 2, T2 is 20, then planet gear 3, it's having 40 teeth, gear 5 it's having 100 teeth internal gear, ring gear, and ring gear is fixed. So N5 is ring gear 5 is fixed. So N5 equal to 0. Then gear 2 is rotating at 60 rpm. N2 is minus 60. Counterclockwise you will take minus and clockwise you will take positive. So minus 60 rpm. We have to find out the arm rotation. N4 we have to find out. Tabular method we will use here. So first fix the arm number 4 and rotate gear 5. Then arm is fixed, so here it will come 0. For gear 5 it will come plus 1 rotation, and for gear 3, gear 5 is internal gear, gear 3 is external, so positive T5 divided by T3. Here for gear 2 and gear 3 they are externally connected, so minus will come, minus T5 by T3 into T3 by T2. T3 cancel, minus T5 by T2. Multiply x here, plus x into T5 by T3, here minus x into T5 by T2. Add y plus x into T5 by T3, y minus x into T5 by T2. Actually gear 5 is fixed, so this value, this is N5 equal to y plus x, it's fixed, so it's 0. So from here y equal to minus x. Then for arm we have to calculate. The arm is 4. This is number 4. So n4 we have to calculate y value. So given gear 2 is minus 60 rpm. So here this value is minus 60 rpm. So y minus x into t5 by t2, it's equal to minus 60. So y is minus x. So minus x, all minus will cancel. T5 by T2 equal to 60. So from here x into 1 plus T5 is 100 and T2 is 20. 100 by 20 you will get 5 equal to 60. So x equal to 10. So x equal to 10. From here we will get y equal to minus x. Y equal to minus x. So we will get minus 10 rpm. So it's also counterclockwise. So n4 value is minus 10 rpm or 10 rpm counterclockwise. This is the answer. One more question I missed. This is also very important question. A solid shaft of diameter small d and length capital H is fixed at both ends. Find the maximum shear stress in the shaft. So here this length is L by 4 and this side 3 by 4 L. TO is the torque at C point. So from here maximum shear stress we have to calculate. So we know for this side, AC side, TAC is directly we can write T into 3 by 4 L divided by L 3 by 4 TO, and TBC it's TO into this side distance. For BC you have to multiply this side distance, and for AC you have to multiply this side distance. TO into this side is L by 4 divided by total length L. TO by 4. And we know TAC plus TBC equal to total torque TO theta AC plus theta BC equal to 0. So theta AC equal to minus theta BC. So from here TAC LAC divided by GJ AC equal to TBC LBC GJ BC. GJ is same, we can cancel. If we solve this one, same. This one we can, if you do directly, we will get these two values. If we solve, same value you will get. If you won't give this negative sign on, you just calculate the magnitude, then same value you will get. Then we have to find out the maximum shear stress. T by J equal to tau S by R. So here maximum is 3 by 4 TO. So tau S maximum is, instead of T we will write 3 by 4 TO divided by RJ. 3 by 4 TO divided by J is 5 by 32 D to the power 4 divided by D by 2 to 16. Then 3 by 4 TO into 16 by pi dq, 12TO by pi dq. This is maximum value. So from options we have to check B is the answer. Here in this question, to calculate this relation, any method you can use, this method or this method. This is method 1, directly you can calculate, or this is method 2. Any method you can use. A vehicle suspension system consists of a spring and a damper. The stiffness of spring is 3.6 kN per meter and the damping constant of the damper is 400 Newton second per meter. If the mass is 50 kg, then the damping factor and the damped natural frequency you have to calculate. So stiffness K equal to 3.6 kN per meter and spring constant, damping constant of the damper, this is C, is 400 Newton into second per meter and mass M is 50 kg. Damping factor zeta, it's C by Cc. This value we have to calculate, and damped natural frequency omega d. Formula is omega n square minus a square root over. So Cc is 2 into root over of Km. So from here C is 400 divided by 2 into K value is 3.6 into 10 to the power 3, it's in kilonewton, into mass is 50. 2 here we will get 200. So 36 into, if you put the value, C by Cc is C by root over of K into M. K is 3.6 into 10 to the power 3, M is 50. Finally we will get 10 by 21. So from options, 10 by 21, it's around 4.71. So C not possible, D also not possible. Then we have to calculate omega D value. Omega D is omega n square minus a square root over. A is C by 2m. So A value is C by 2m. 400 divided by 2 into 50, it's 4. Omega n is root over of K by m. 3.6 into 10 to the power 3 divided by 50. Finally we will get omega n value 72 root over. So put the values, omega d equal to 72 root over square minus a square, it's 4 square whole root over. So we will get 56 root over, it's 7.5 radian per second. Then we have to check options whether they are in radian per second or not. So from option, they are in hertz. So we have to calculate, convert it into hertz term. Fd is omega d divided by 2 pi. It's 56 root over 56 root over divided by 2 into 3.141. So 56 root over we will get around 7.5 divided by 2 into 3.16, we will get 6.2 something. So 1 point something, this will be answer. From options, only A. B not possible because here 7.42. So A is our answer. A uniform rod of mass capital M and length capital L hinge at one end as shown in the figure. A force P applied at the distance of 2L by 3 from the hinge so that the rod swings to right. The reaction at the hinge is how much? So we have to calculate the reaction at the hinge. We can convert this figure like this. This is the hinge point. P is the upward load, mass M at the midpoint, capital M downwards, P is upwards. This distance is totally L, 2L by 3, this distance is, so half distance is L by 2. So points we can write A point, here B point at middle, and C at end point, D at P point. So take moment along A point, it's equal to 0. M into L by 2, M is the mass, minus P into 2L by 3, it's equal to 0. So from here M equal to P into 2L by 3, L cancel, so M equal to 4P by 3. Reaction it will act here. That this is RA. RA value we have to calculate. So RA plus P, we can summation of all vertical forces, this is 0. RA plus P equal to M. M is the mass, so you have to multiply G also. Here also we should multiply G. Multiply G, or M into G we can write total weight W. Then we will write here W equal to 4P by 3. So here M into G, we can write RA plus P equal to W, mg is W, 4P by 3. So RA value is 4P by 3 minus P, we will get P by 3. This is our answer. So from option C is our answer. Horizontal direction no force, so this reaction force or RA along horizontal direction, this is 0. This is the end of part 3. Next question onwards I will solve in part 4. Thank you friends. Thank you for watching my video. Thank you.